Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today. For exam FM on financial mathematics, a common stock will pay 2 per share in dividends at the end of the current year. You are given that the earnings of the corporation increase 7% per year indefinitely, the number of shares increases 4% per year indefinitely, and that the corporation plans to continue to pay the same percentage of its earnings in dividends. The price of the stock 10 years from the beginning of the current year will be X. At that time, the annual effective interest rate is assumed to be 10%. Calculate X using the dividend discount model. And here's the solution. The key idea of the dividend discount model is that the price of a stock equals the present value of the future dividends to be paid by that stock, and this calculation is done per share to find the price for one share. Current dividend paid at the end of the year is 2, and it will grow at 7% every year, because earnings grow at 7%, and the same fraction of earnings is paid out in dividends. However, the allocation per share will be reduced by 4% every year because the number of shares increases 4% every year. Thus, the dividend per share in the 10th year will be 2 times 1.07 to the 10th because of a 7% per year growth, but divided by 1.04 to the 10th because of a 4% reduction every year due to increase in the number of shares. And it will be paid at the end of the 10th year, at time 11, so its value at time 10 will be 2 times 1.07 to the 10th over 1.04 to the 10th times 1 over 1.1 because the interest rate applicable is 10%. Next dividend per share at time 12 will be 2 times 1.07 to the 11th over 1.04 to the 11th, and its value at time 10 will be 2 times 1.07 to the 11th over 1.04 to the 11th times 1 over 1.1 squared. This will continue infinitely or into infinity, and therefore the value at time 10 will be that 2 times 1.07 to the 10th over 1.04 to the 10th, dividend for year 10, and then multiplied by 1 over 1.1 for the payment at time 11, plus 1.07 over 1.04 for the growth of the earnings and growth of the number of shares in the 11th year, times 1 over 1.01 squared for discounting from the end of the 11th year, time 12, to time 10. And then next year again increase by the same factor, and reduction in allocation per share by the same factor, and now discounting for 1 more year, but it's basically the same pattern. Now we factor out 2 times 1.07 to the 10th over 1.04 to the 10th times 1.1, and the expression in parentheses, once you factor out 1 over 1.1, it becomes a geometric series, starting with 1, with a ratio of 1.07 over 1.04 times 1.1. So this is the sum from n equal to 0 to plus infinity of 1.07 over 1.04 times 1.1 to the nth. And of course the sum of such a geometric series is 1 over 1 minus the ratio of the series. So this becomes 2 times 1.07 to the 10th over 1.04 to the 10th times 1.1 times 1 over 1 minus the ratio of the series, which is 1.07 over 1.04 times 1.1. And then if we take 1.04 to the first power times 1.1 to the first power from the denominator of the first fraction and multiply the second fraction's denominator by it, then the second fraction would become 1 over 1.1 times 1.04 minus 1.07, and the first fraction becomes 2 times 1.07 to the 10th over 1.04 to the 9th. And then we just calculate this is approximately 37.3539041, and that's answer C. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.